Good morning, everyone. Alrighty, today we're going to be moving on with 4C, which was supposed to be taught in two parts, but we're going to be looking at the whole lot in just one hit today to make up for the stuff missed on Monday. In our last class, we looked at how we could use our calculator to determine the values for A and B, values in our least squares regression line. But the thing we didn't really look at is what these values of A and B mean. So the first thing we're going to be looking at today is how to interpret these values and what they mean. And the second thing we're going to be looking at is how we can now use this equation to then make predictions about our data. So, as we saw last class, our regression equation is in the form y equals a plus bx. Now, our value for b is our slope. And another word for slope that you'll see used all the time is you'll also see this referred to as your gradient, or you might see it referred to as a rate as well at times. So there's some other words for slope that you might come across. And the slope basically tells us the steepness of our line. It's telling us how much y is changing as the x variable increases by 1 unit. And basically, the bigger the value of the slope, the steeper your line is going to be. It also tells us the direction of our data. If we have a positive b value, then our y variable is increasing as x increases, and we will have a positive graph. Whereas if b is negative, then that means that y is decreasing as x increases. And then our a value is our y-intercept. Now this is otherwise known as, sometimes it's called the vertical intercept. And it's the value of the graph where the line crosses over the y-axis on a Cartesian plane. And it predicts the value of your y variable or your response variable when the explanatory variable is 0. So when we're asked to interpret these values, we have, again, some sentences that we can use. So I've got our two sentences here. When we're asked to interpret the slope, the bits in the brackets are the part that we're going to substitute in for. So the rest of the sentence remains, and then we pick either increases or decreases. And then we should have units on the end there as well. So on average, for every 1 unit increase in the explanatory variable, the response variable will either increase or decrease. You have to pick one depending on if it is positive. So increase if it's positive, decrease if it's negative, by the gradient units. I've also got a sentence here for interpreting our y-intercept, but I don't like it very much. We can also say that it predicts you could say it predicts that when the explanatory variable is 0, and so we could say that instead will be so it predicts that when the explanatory variable is 0, RV will be A units. So we're talking about it being a prediction rather than making a full-blown statement. And then our regression line can then be used to make predictions. So we've done a couple of these already, just where we've had to do some substitutions. So in these, our least squares regression line connects one variable to the other. So if we know one variable, we can use the least squares regression line to predict the outcome of another. So in this instance, in this example, we've got an investigation that relates food energy content to fat content in chip sizes, and we've got a least squares regression line. And we're using the least squares regression line to predict the energy when it's got a fat content of 8 grams. So energy, why you know right now? Oh, our energy content in this case is going to equal 27.8 plus 14.7 times by a fat content of 8. So I'm going to chuck that into my calculator. 27.8 plus 14.7 times by 8. So that will be 145.4, and energy content is being measured in calories. So this is there was our fat content that we substituted in. All right, now this is a very common second part of this question. Interpret the slope of the least squares regression equation. So our slope is our b value, which in this case is 14.7. So on average, for every 1, and we're talking about fat content is being measured in grams. In fat content. So for every 1 gram increase in fat content, energy content increases because our slope is positive by 14.7, and it's being measured in calories. And I'm gonna sneeze. Sorry. Sorry. I apologize. Blah. All right. So there's some exam questions for you to have a go at, or one exam question for you to have a go at. In fact, well, we could just have a look at this one. No, you guys can have a crack at it. Let's have a look at interpolation and extrapolation. So when we calculate a least squares regression line, that line only applies to the data that we have collected over that particular data range, because we don't actually know if the relationship is going to continue as we see it outside that data range. So a good thing to think about here is, like, for a while you're growing, your age and your height have a positive correlation, because as you get older, you get taller. But you reach a point in your life where you stop growing. So it's not like as you age into your 50s, you just continue to get taller. So that regression equation between age and height only lasts for a certain amount of time. And then that line then no longer is appropriate. So it wouldn't be appropriate to use a least squares regression equation to calculate the height of someone who's in their 90s, because it would make a prediction that is well outside our data range. So this is where we talk about interpolation and extrapolation. and this is used to determine the reliability of predictions. So if you ability of predictions, if we see any kind of question that asks about how reliable something is, it's asking us to tell us whether we're interpolating, which is where we make a prediction that is inside our data range, or an interpolation are predictions that are reliable, whereas extrapolation is predictions that are outside the data range, and those predictions are less reliable. Now, when we say inside the data range, we're talking about within the smallest and highest data points, not what's on your graph, but the actual data points themselves. So if we have a look at this example here, I'm sorry for sniffing at you. The smallest data point is here, and our largest data point is here, and anything inside those data points is interpolation, whereas anything outside those, the smallest and largest data point, is extrapolation. So it's not just necessarily whether the value is on the graph or not. Like, extrapolation is not just things that are greater than 400. Extrapolation is any value that is greater than your or smaller than your largest or smallest data values, respectively. So here we have a scatter plot that you can't see the picture of because I need to scroll across, but that's okay. Oh, look. Oh, no, it's hearing test and age, not age and height. There's our scatter plot, though. Yay! All right, and the first thing we're going to do is we're going to predict the score for a 94-year-old person. All right, so score is going to equal 3.9 minus 0.024 times by an age of 94. So 3.9 minus 0.024. Oh, go away. Times by 94 equals, so we get 1.644. All right, we've made our prediction, and then we're being asked to say if it is reliable. So 94 is well above, so our highest value is just below 60. So 94 is well outside our data range. So this is a 2-mark question. Is it likely to be reliable? No. That would get you 1 mark. Give reasons why. Because we are extrapolating. And examiners want to see you use the word extrapolating or interpolating rather than saying that it's inside or outside the data range. They want you to be using the terminology here rather than talking about it being inside or outside. So using the correct terminology is important in that kind of question. All right, there's some more exam questions, or 2 more exam questions for you guys to have a go at. Alrighty, let's have a look at the rest of 4C now. I'm just going to change pages here. Oh. All right. So we're now going to have a look at residual values. Now, if you find the residual of something, if you've got something like residual, oh no, I'm shit at language. So let's just, residual means leftover. It's like something that is left over. And residual values measure the difference between what the line predicts a value should be and what the actual value is. And we use residual values and residual plots to determine if the data is linear. So in other words, it's used to justify your form. So form is either linear or non-linear. And we use our residual values to decide whether or not our data is in fact linear. So when we calculate these residual values, we need to use two values to find what the residual will be. Our residual is the actual value minus the predicted, or our least squares regression line value. So if we have a look over here on our graph, these data points are the original points on the graph. And at each of those points, the line is going to predict a particular point as well. So on the line, these are our corresponding line values to those residual points. And the residual value is the difference between what is plotted and what the line suggests the value should be. So sorry, I just lost myself. Someone came to my door. Anywho, the actual values are generally either given to you on a scatter plot, or they're given to you in a table, or they generally tell you in some other way. The predicted values you usually have to work out for yourself using your equation of the least squares regression line. So let's have a look at this example here. This data shows the relationship between the number of careless errors on a test and the test score. And we're given the equation of the least squares regression line as well. So we know that careless errors are x and test score is y. And we're being asked to calculate the residual value for a test score of 12. So we're using this data here. So our residual is equal to the actual minus the predicted score. And we've got, and it's that when x equals 6. Alright, remember we're substituting the x values here. We've got a test score of 12, but that's our y value. We need to, and the corresponding x value is 6. So we know that the actual value is 12, and at the moment we don't know our predicted. So let's work out our predicted. So our predicted value is equal to 17.5, minus 1.08 times by 6 careless errors. So our least squares regression line suggests that when I make 6 careless errors, I should get a score of 11.02. But I got an actual score of 12. So that goes in over there. So now find the difference between my actual and my predicted. I'm going to do 12 minus 11.02. And our residual value is 0.98. Now this is a very common exam question, and they're not often done very well. And we're going to have a look at a few more of those as we go through. But for now, let's have a look at how we now interpret residual plots. Because like I said before, our residual plot determines whether our original data is linear or non-linear. And a residual plot is formed by calculating a residual value for every single value in your table. And you can do this by hand, but we're actually going to have a look in tomorrow's class at how we can do this using our calculator. But for now, let's say that these residual plots are constructed for us. And what we're looking is for a random pattern. So if the residual plot shows random points all over the place, then our original data will be linear. But if there is a clear pattern, such as in this one where we have kind of like a curve, or it could be a curve that looks like this, then that suggests that our data is nonlinear. So when we're presented with a residual plot, such as this one here, we'll be asked, does the residual support the idea that the data is linear? And explain our answer. Again, this is a two-part question. Does the residual plot support linearity? That's yes or no. Explain our answer. That's going to be whether or not the residual plot is random or shows a pattern. So in this case, if we look at this residual plot, all of our values seem to be all over the place. So does the residual plot support the assumption of linearity? Yes. That would get us 1 mark. Why? The residual plot is random. And shows no clear pattern. And that would get us our 2nd mark. No. Now I know I've gone over this stuff pretty quickly today, but we're going to spend some time tomorrow in class looking over these exam questions on both residual values, go away all stuff, and also interpreting and predicting values. So if you want to get it started on that, you can. But in tomorrow's class, we will be working on these 2 lots of exam questions. Just so that you guys are a bit more familiar with the stuff that we have gone over today, because I realize that I've crammed a lot into just this one session. All right, but we do have a double session tomorrow, so everything's going to be a-okay. Well, that's not what I wanted at all. I'm trying to stop the video. You think I can figure out how to do that? Nope, because my little thing's disappeared. So just talk amongst yourselves while I stop this.